friends, this video on mechanical properties of fluids part 12 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from part 1 to part 11 before going ahead with part 12. The problem says two syringes of different cross sections without needles filled with water are connected with a tightly fitted rubber tube filled with water. Diameters of the smaller piston and the larger piston are 1 cm and 3 cm respectively. Find the force exerted on the larger piston when a force of 10 Newton is applied to the smaller piston. If the smaller piston is pushed in through 6 centimeters, how much does the larger piston move out? To understand this, just try to look at the first sentence. Two syringes of different cross-sectional area filled with water. That means, let us suppose you have two syringes. This is one syringe and this is another syringe. Both have different cross-sectional area. One has a smaller cross-sectional area and the other has a larger. They are connected with a tightly fitted rubber tube filled with water. That means these two syringes are connected somewhat like this. So this is a rubber tube which is filled with water. Right? So if you observe, it is the same setup which we used for hydraulic lift or hydraulic brakes. So it says that the diameters of the pistons are given as follows. So let us suppose for the smaller piston, we say that the area of the smaller piston is A1 and the force applied on smaller piston is F1. Similarly, we say that for the larger piston, the area is A2 and the force which develops across the larger piston is F2. So what is given in the question, according to the question, A1 is equal to cross-sectional area would be pi r1 square and radius is given as 1 centimeter. So we can say pi, this is not radius, basically diameter is given, so we can say radius would be 1 by 2 square. Similarly, what is A2? A2 would be pi r2 square. Now what is r2? That is 3 by 2 square. So these are the cross-sectional area. And also it says, now let us solve the first part first. The first part, it says find the force exerted on the larger piston. That means if you apply a force F1 on smaller piston, a pressure will be exerted on this. This pressure will exert a force F2 on the larger piston, right? So in the first part, we have to calculate the force that is exerted on the larger piston. And it says that the force that is applied on the smaller piston is 10 Newton. So what we can say? We can say that the force which is generated on the larger piston is nothing but pressure into area 2. Now this pressure, how is this pressure generated? It is generated due to F1. So we can write this pressure is nothing but F1 by A1. So this is F1 by A1 into A2. So we can put the value of F1 as 10 Newton. What will be A1? A1 would be pi 1 by 2 whole square. If you observe, these were in centimeters, but even if you change it in meters, A2 by A1, so the ratio will still remain the same. So here A1 we can write pi into 1 by 2 whole square. A2 we can write pi into 3 by 2 whole square. So this pi and pi will get cancelled. So we get this as 90. So F2 will be 90 newtons. That means this much force will be exerted, 90 newtons will be exerted on the larger piston. So just see, if you go by data, you can observe that by applying such a small force of 10 newtons, you were able to get an output, or you were able to get a force of 90 newtons on the other end, right? So the part A is solved. Now part B says, if the smaller piston is pushed in through 6 centimeters, that means when you apply the force F1, this smaller piston moved a distance of say 6 centimeters. So it says how much does the larger piston move out. So if the smaller piston moves in, this piston will move out. It will reach somewhere here. So we have to calculate this distance. So now let us solve the second part. As we know that water is an incompressible fluid, that is, the change in volume is not reduced due to application of pressure, right? Therefore, we can say that when the smaller piston moves in, the volume which the smaller piston covers will be equal to the volume moved outwards by the larger piston. That means volume moved by smaller piston will be equal to volume moved by larger piston, right? So this volume is moved inwards, and this volume is moved outwards, right? So what would be the volume moved inwards? It would be the cross-sectional area into displacement. The cross-sectional area of the piston into displacement is the volume that is moved by the piston, right? So this would be A1 into displacement will be equal to A2 into displacement 2. This is displacement 1. So what is A1? Cross-sectional area of the smaller piston was pi 1 by 2 whole square into displacement is 6 centimeters. So this is equal to A2 is pi into 3 by 2 whole square into displacement 2. So this pi and pi will get cancelled. So we can say displacement 2 is equal to 1 by 4 into 6. 4 divided by 9. So this 4 and 4 will get cancelled. So we get 3 to the 6, 3 3 is a 9. So this is 2 by 3. So this is 0.67 centimeters. So this will be the displacement by the larger piston. That means when the smaller piston, let us say this is the smaller piston, this is the larger piston. They were connected this way. That means when the smaller piston was moved inward, the larger piston was moved outward. So the volume which the smaller piston covered was equal to the volume which the larger piston covered. So how did we calculate volume? Volume is nothing but the cross-sectional area of the piston, this cross-sectional area multiplied by this displacement, right? So that would become the volume of this material. Let us suppose it moved till here. So volume of this part would be the cross-sectional area into displacement. So that is what we did. Cross-sectional area into displacement is equal to again cross-sectional area into displacement. And we put the values and found out the answer. So I hope you understood how do we approach problems related to fluid pressure transmission, or how do we apply Pascal's law in our day-to-day life. So that was basically most of all we were supposed to study about fluids at rest. So the most important thing that we studied in static fluids or fluid statics is the Pascal's law, application of Pascal's law and their examples, and also how to solve numericals related to Pascal's law. Now,
thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.